All right, let's dive right into this explainer. Today, we are opening up a definitive architectural blueprint for EdTech professionals, instructional designers, and really anyone seeking to master the exact science of customization. I mean, if you've ever wondered how the absolute best learning platforms seem to magically know exactly what you need right when you need it, well, you are in the right place. We're going to look under the hood of personalized learning systems, moving way past your basic run-of-the-mill recommendations to figure out how to build a dynamic, truly adaptive EdTech ecosystem from the ground up.
And this setup here brilliantly illustrates exactly why generic, one-size-fits-all content delivery is pretty much doomed to fail from the start. Look at these two wildly different scenarios. On one hand, we have a passionate K-pop fan. On the other, a corporate business professional who just wants to expand their market into Korea. If you take an incredibly well-produced piece of content, let's say the history of idol groups, and deliver it to both of these learners, the results are going to be night and day. For the fan, it's highly engaging. For the business professional, it's totally irrelevant, frustrating, and frankly, a great way to get them to close their laptop. It doesn't matter how amazing your educational content is. If it hits the wrong learner, its effectiveness is instantly cut in half. We absolutely have to solve this mismatch.
So, to solve it, we're going to follow a highly structured three-step blueprint today. First, data-based learner understanding and persona definition. Second, adaptive learning paths and content mapping. And finally, system optimization through data analysis. Let's not waste any time and get right into it. Step 1. Data-based learner understanding and persona definition.
You see, creating a truly personalized learning engine requires going much, much deeper than simple demographic labels. I mean, tagging someone as a 20-something female gives us practically zero actionable insight into how she actually learns. We need a systematic way to profile our learners across 4 critical variables. Sure, demographic variables cover the basics like age and occupation, but we've got to layer on psychological variables, things like motivation, personality, and learning style. Then, behavioral variables. What are their completion rates? How often are they actually participating? And finally, contextual variables. Are they learning on a smartphone during a packed, noisy commute or on a desktop late at night? When you're looking at niche subjects like Korean culture, learners often have completely unique psychological drivers. Someone motivated by an intense fandom culture has a very different internal fire than, say, a quiet academic researcher.
And within those psychological variables, we also have to map out exactly how they absorb information. The VARK model is a fantastic tool for this. Just think about your own learning style for a second. Are you someone who prefers visuals, like diagrams and charts? Are you an auditory learner who just thrives on lectures and good discussions? Do you prefer to read and write text? Or are you kinesthetic, needing that real-world hands-on experience and role-play? If our K-pop fan is a hardcore kinesthetic learner, tossing them a dense 20-page textbook isn't just boring, it's practically a sedative. Once we have all those rich, detailed variables, we synthesize them using a really structured 5-step persona development methodology. We aren't just guessing here. We start with data collection, from real surveys and interviews. Then we move to pattern discovery, finding those common threads. Next is archetype definition, where we isolate the core characteristics. Step 4 is storytelling, and this is where we breathe life into the data. We give them a name, a face, a whole background story. Imagine creating a persona named Sarah, a US college student majoring in Korean, who struggles with formal grammar, but absolutely excels at conversational slang. Finally, we validate this persona against real-world testing. These personas become the ultimate compass for literally every design decision we make moving forward.
Which brings us to step 2, adaptive learning paths and content mapping.
Now that we have our living, breathing personas, we have to connect them to customized learning paths, exactly like a personal trainer designing a workout routine for a very specific body type. But the absolutely crucial point here is understanding the difference between customized and adaptive, because honestly, the industry confuses these two all the time. Customized learning is basically just giving the learner a static menu. You tell the system you're a beginner, and it gives you the pre-made beginner path. Boom, done. Adaptive learning, however, is alive. It involves real-time, algorithmic adjustments based on the learner's ongoing responses. If an adaptive system sees you repeatedly failing a grammar quiz, it instantly reroutes you to foundational materials before you even realize you're struggling. And that is what we want to build. Truly adaptive systems.
So how do we actually build that adaptive brain? It generally progresses through 3 technological stages. It starts simple with basic if-then rules. For example, if the learner is a beginner and they are interested in K-pop, then serve the module on basic lyrics. It's simple, but it works. Next, we level up to collaborative filtering. Think of this as the Netflix model. It recommends paths based on what similar learners succeeded with. Finally, the absolute gold standard is predictive machine learning. This involves using past data to predict future behavior. An advanced ML system can literally predict the exact module where a specific persona is statistically most likely to drop out, and it deploys an intervention before they even think about clicking away.
Let's see this content mapping in action to really drive it home. Let's say our core topic is Korean traditional food. We don't just have one generic video for everyone. Look at how this maps out. For our fan learner persona, the algorithm serves up content about traditional foods recommended by their favorite idols. For the academic learner, the system completely shifts to content on the historical changes and regional characteristics of the food. And for the professional learner, it pivots again to teach business dinner etiquette and proper menu selection for clients. It is the exact same underlying subject, uniquely mapped and adapted based entirely on the learner's core internal motivation.
And that leads us to step 3, system optimization through data analysis. The truth is, those adaptive paths we just designed, they are never perfect on day one. Never. They require a robust data ecosystem to constantly refine them over time. And this system feeds on 2 specific types of data. Explicit data is what the learner consciously gives you: survey answers, direct feedback, test scores. But the real magic, the absolute goldmine, lies in implicit data. This is the behavioral exhaust the learner silently leaves behind. Where exactly do they click? What is their dwell time on a specific graphic? Do they constantly rewind a certain 5-second clip of a video? Implicit data is often the most valuable because it comes from silently observing the raw logs. Learners might tell you on a survey that they completely understand a concept, but their implicit data, pausing and rewinding multiple times, tells you the truth. They are actually struggling. But hey, before we can analyze any of those clicks or test scores, we have to establish the 3 absolute pillars of data quality management. First, accuracy. We must rigorously check for errors and duplicate entries. Second, completeness, checking for missing data points that could totally skew our algorithms. And third, consistency, ensuring uniform formats and units across the entire platform. If you don't have these 3 pillars firmly in place, your advanced machine learning algorithms are basically flying blind. They're completely useless. In fact, the source material highlights an incredibly powerful reality. Bad data leads to bad decisions. It's that simple. If your system has dirty, inconsistent data, it's going to incorrectly profile your learners and send them down the completely wrong paths. That causes immense frustration and ultimately platform abandonment. Quality control isn't just some boring IT chore. It is the literal lifeblood of personalization.
Now, once our data is squeaky clean, we can run continuous experiments like A/B testing. Imagine we notice a steep drop-off in a specific learning module. We can deploy version A, a standard video lecture followed by a quiz, and pit it head-to-head against version B, an interactive simulation followed by that same quiz. By closely monitoring the data, we visualize the learning curve in real time. We can pinpoint the exact moments of disengagement. If version B yields a 20% higher completion rate, the system learns from this immediately and automatically begins routing more visual and kinesthetic learners straight to the simulation. This is exactly how we deploy proactive dropout prevention strategies. So, how does this all build into an actual minimum viable product, or MVP, system architecture? Well, you don't build the crazy predictive machine learning engine on day one. You start right here. Step 1 is the input layer, gathering those explicit and implicit data sources we talked about. Step 2 is the processing layer, where our initial profiling algorithms and basic if-then engines live. And step 3 is the output layer, which translates that processing into useful dashboards for the teachers and concrete content recommendations for the learner. You start with static, rule-based paths in your MVP, and as your data pool grows over time, you scale up to those real-time dynamic predictive models.
As we wrap up this architectural blueprint, it is absolutely vital to bring all this complex tech back to its human core. As the curriculum reminds us, personalization is a philosophy, not just technology. The data, the algorithms, the architectures, they are all just tools. The ultimate goal of building an adaptive EdTech ecosystem is to deeply, genuinely respect the incredibly diverse backgrounds, motivations, and learning styles of every single individual who logs in.
Which leaves us with this final, critical thought. I want you to take a hard look at the educational platforms you build, use, or manage every day. Are your algorithms merely tracking data points on a spreadsheet just to boost completion metrics? Or are they intelligently designed to truly respect and adapt to the learner's completely unique journey? It's a tough, challenging question, but answering it is the key to mastering the science of customized education. Thank you so much for joining me for this explainer.